Welcome to the Chapter 11 practice test for geometry. The first two questions say find the measure of the arc or central angle indicated. Assume the lines which appear to be diameters are actual diameters. Diameters cut the circles in half, which gives you 180, or you can use total angle measures of 360. You can even look for boxes that make the 90 degrees. So on number 1, they're asking for the arc KM. So you're going to highlight where KM is at. That means they want this angle and this angle together. But this is the only one that's missing. So you take all the other angle measures, add them up, subtract it from 360. You'll get 127 plus the 30 that's next to it, so it's 157 degrees. Number 2, arc JLN. So you want to make sure you go this way. These two lines create vertical angles, so they should be congruent. But you also have a diameter here, and you have a diameter here. So either way, you're going to start with 180, subtract the two angle measures that you know, and you'll get 67. So these are both 67. So you take the 180 plus the 67, you get 247. Numbers 3 and 4, the directions say find the length of the segment indicated, round your answers to the nearest tenth if necessary. What happens is a right triangle is created, so you're going to use the Pythagorean theorem, using the leg squared plus the leg squared equals the hypotenuse squared. Use your calculator to square these numbers, subtract the 144 from both sides, and then take the square root, round to the nearest tenth, and you get 5.3. Same thing over here, but you need to know that if that radius is perpendicular, that it is the bisector, meaning both these segments are the same length. Okay? So again, you're going to use the Pythagorean theorem using x for the leg, 13.1 for the other leg, 15.5 for the hypotenuse. Square them, subtract them, take the square root, round to the nearest tenth. Numbers 5 and 6. They want you to find the measure of this angle down here. So you need this arc right here, which is the only arc you don't know. So you start with 360 for the whole circle, subtract the two that you know. That gives you an arc of 124. So you're going to take half, which is the same as dividing by 2, and it's 62 degrees. On number 6, you're going to notice that this is a diameter, which makes this 180 degrees, so the angle over here is 90. This arc right here is 68, so half of that is 34. Then you've got this triangle inside, you know two of its measures, so start with 180, subtract the two you know, and that gives you the angle that's left, which is 56 degrees. Numbers 7 and 8, you're going to find the perimeter of each polygon. Assume that the lines which appear to be tangent are tangent. So anytime you have tangent, two segments that are tangent from the same point, they're going to have the same measure. So if this one's 13, this one's 13. If the whole thing is 18.5, subtract the 13, you get 5.5, which makes this 5.5. This is 5.5, subtract it from 16.7, that makes that 11.2, so that's 11.2. This is 19.6, subtract the 13, that makes that 6.6, which makes that 6.6. Take all eight pieces, add them up, you'll get 72.6. Same thing here. This is 8.4, this is 8.4. This is 7.5, this is 7.5. The whole length is 17.5, that's 10. So that's 10. So add up all 6 pieces, you'll get 51.8. To the top of page 2, find the measure of the arc or angle that's indicated. The angle right here is inside the circle, so you're going to add the two arcs associated with it and take half. So I added the 201 and the 55, got 256, divided by 2, you get 128. Number 20, the vertex is on the circle, so you're just going to take half. That would be if you were given the arc and you're going to the angle, but instead you're going from the angle to the arc, so you're actually going to double it, and you get 116. Number 11, the vertex is on the circle, so you're going to take half. But since you're going from the angle to the arc, you're going to double it to get 96. That gives you that much of the arc, but they want this much of the arc. So total 360, subtract the piece you know, you get 264. Number 12, the vertex is outside the circle, so you're going to subtract and take half. So you're going to do the larger arc minus the smaller arc. You get 90, divide that by 2, that gives you an angle measure out here of 45. Number 13, the vertex is outside the circle, so you're going to subtract and then take half. First, I had to figure out what this arc measure was. So I started with 360, subtracted the 115 I knew, so that made that arc 245. So 245 minus 115 is 130. Take half of it, you get 65. Number 14, the vertex is outside the circle, so you're going to subtract them and take half. So I called this x, subtracted the 65, divided it by 2, set that equal to 30, made that into a proportion, did the cross product. So 1 times x minus 65 is just x minus 65. 2 times 30 is 60. Add the 65 to both sides. I got 125. Down at the bottom are your segment relationships inside of circles. So they want you to solve for the variable. And anything that looks tangent is obviously tangent. Okay? So the first one is the chord product theorem. So we're going to multiply this piece times this piece, which is the 5x. We're going to multiply this piece times this piece, which is the 4 times 10, which is 40. Divide both sides by 5, so we get 8. Number 16 is the secant tangent. So you want to do the length of the whole thing times the outside. Set that equal to the tangent squared. Okay, so I distributed on the left, and on the right I squared it with my calculator. Subtract the 729 from both sides, and then divide both sides by 27, so you get x equals 21. 17 is your secant, so you need the whole thing times the outside, whole thing times the outside. Distribute on the left, subtract the 64 from both sides, divide both sides by 8, and you get 13. Number 18, same thing, secant, so you're going to do the length of the whole thing times the outside. Set that equal to the whole thing times the outside. Distribute on the left here. Subtract the 81, divide by 9, and that gets you 11. Top of page 3, you're going to find the measure of the arc or central angle indicated. Looking always for 360, 180, or 90. Those are always going to help you. So for number 19, I used the 360, which is the total. And we wanted the measure of UV. So from here to here, of course, the only one that's not listed. So altogether, they should be 360. So I subtracted the 4 that I knew and got 55. On number 20, we want angle KFG, this one right here. So I put an X. I looked for diagonals. I got one right here and right here, which makes these vertical angles, meaning they're the same measurement. And then I just added the 56 and 45, got 101, which makes this 101. Number 21. This creates a right triangle, so I use the Pythagorean theorem. I use this leg squared plus this leg squared, set it equal to the hypotenuse squared, and then did quite a bit on my calculator. So x squared, what did I do? Multiplied 8.4 times 8.4, got 70.6, added that to the 100, took the square root, rounded it to the nearest tenth, got 13.1. 22, same way, creates that right triangle, so you're going to use the Pythagorean theorem. We've got x squared plus 8.5 squared equals the hypotenuse 11.1 squared. Square it on the calculator, subtract the 72.525 from both sides, take the square root, you should get 17.1. Numbers 23 and 24 says find the measure of the arc or the angle indicated. So on 23, they want the angle. So we're going to take half. But first I had to find the arc measure by subtracting the two arcs that I knew from 360. Number 24, we wanted this this question mark over here. So this arc, so what did we do? I took the 108 and doubled it. That means this much of the arc is 216. This much of the arc is 46. So I subtracted those two from 360, which left me with just this much, which is 98. 25 and 26, we want to find the perimeter of each polygon. So we're going to assume the lines that appear to be tangent are tangent. So if this piece is 2.3, this piece is 2.3. If this one's 9, this one's 9. If this whole thing is 15.5, subtract the 9, you get 6.5, which makes that 6.5. The length of this whole side is 14.1, and this is 6.5. Subtract it, and you'll get 7.6, which makes this 7.6. Then you're going to take all 8 pieces, add them up, you get 50.8. Number 26. This is 9.3, this is 9.3. Subtract that from the 20.3 to get 11, which makes that 11. This is 10.5, that makes that 10.5. Add all 6 pieces up, you'll get 61.6. And page 4. Find the measure of the arc or angle indicated. So they want this measure down here. The vertex is on the outside, so you're going to subtract and then take half. So take the larger arc minus the smaller arc. You get 96. Divide that by 2, you get 48. Number 28, we want this angle right in here. If the arc is 144, you just divide it by 2. Number 29. I believe the question mark was right there. I just wrote over the top of it. So I called that one 360 minus x and that x. But technically I should have made that x and that 360 minus x, because in the end it kind of messed me up a little bit. So you go 360 minus x divided by 2 is equal to 68.1. Then I made it into a proportion, did the cross product, and I solved for x, but that gave me this arc. So then I had to go back and subtract it from 360, which got me 248. Okay, number 30. We wanted this arc out here, which is the vertex is on the outside, so it should be x minus 49 divided by 2 equals the angle measure over here, which is 52. I made it into a proportion, did the cross product, solve for x. Number 31, segment relationships in a circle. So I'm going to go this piece times this piece to get the 5x, this piece times this piece to get the 40, divide both sides by 5. Number 32, this one's the secant. So I'm going to do the length of the whole thing times the outside, the length of the whole thing times the outside, distribute on the left, subtract the 100, divide by 10, get 17. Number 33, this is secant tangent. So you do the length of the whole thing times the outside, set that equal to the tangent squared, distribute on the lest, punch a bunch of stuff in your calculator, subtract 64 from both sides, divide both sides by 8. Number 34, we've got secant again, so we do the length of the whole thing times the outside, set it equal to the length of the whole thing times the outside, distribute on the left, subtract 64 from both sides, divide both sides by 8. You get x equals 19. Number 35, they ask you to find the length of the arc. So I copied down the formula for arc length, which is 2 pi r times the measure of the angle over 360. Substituted in my two values, the radius of 6, the angle measure of 210, typed into my calculator and got 7 pi. Then I took the 7 and multiplied it by the pi button, got 21.99. The units are in miles. Number 36, they want you to find the area of the sector. So I copied down the formula, which is pi r squared, angle measure over 360. The radius was 12, the angle measure is 60. Typed everything into the calculator but the pi button and got 24. Then took the 24 and multiplied it by the pi button and got 75.4. And the units are inches squared.